if you look at, for an example, X-ray imaging, CT imaging, MRI imaging, like we have n number of medical imaging. So being a researcher or being a scholar, to work with any one medical imaging, like we have to select first, then of course, which we need to progress in terms of the research with the medical imaging modality, what we have been selected. And of course, what we are going to do with this medical image. So generally, clinicians, medical practitioners can work and play with medical images. And what is the role of the technologist like us and engineers work with medical images? What we actually going to do? So it's a layman, like the medical practitioners, based on their practice, they can able to diagnose the image. But being a technologist like us, we do not have any experience to directly like getting into diagnosis, but rather we can use the technology like for automatic diagnosis. So what technology which will the whole the research world and industrial world, like the emerging is like AI. So of course, with the help of AI, the technologist, we are going to diagnosis in a medical image, any medical image, which we can say. This is the description of the whole topic which we can see. In this particular concern, if you consider a medical image, like it is a generic name, but like in the last 10 to 15 years, I have been working with multiple medical images. But today I have been presenting one of the medical image, which is called a retinal image. So what is this retinal image, and why we have selected this retinal as a part of the discussions? We have a long description which we need to discuss. Everybody knows the retina is a part of our human eye. So in the retina, like in most of the eye diseases, the symptoms are occurred in first, or we can say the initial symptoms of any eye that has to be generated in the retinal lesions. So like we have n number of eye diseases which we know to us. Let's say, for example, the glaucoma, is one of the dangerous eye disease. We heard about it in many places. And also we have been heard about cataract is also another disease. Like diabetic retinopathy is also another retinal disease. So like we have different 62 different types of eye diseases which are available. So which one among the eye disease, which is called a retinal detachment? The word is very crucial name to understand. Detachment. And also from this word we can understand the literal meaning of the detachment is the retina is generally going to detached from the original position of from the eye, right? So the whole talk will deliver you a study of retinal detachment. So we are working with this particular disease, the retinal detachment, in the last almost 6 years which we are working. And we have been used multiple AI algorithms. It's not only a generic AI algorithm. We have been working with machine learning algorithms, deep learning algorithms, and also we are working with graph neural network algorithms. So we have so many algorithms which we have been working for the diagnosis of this retinal detachment. And the whole journey of the 6 years, which I'm going to quickly share with you in the next 1 hour. So this is the description of the whole topic of our discussion today. Let me start with a simple understanding about the retinal detachment. What do you mean by retinal detachment? The retinal detachment is nothing but it is an eye disease. The nature of the disease is that the retina, which will be detached from their original position, is that positions, how it is detached. If you look at the anatomy of the human eye, which I have been given in the slide, initially the retina, which will be located, the backside membrane of the eye. But what happened due to the effect of this disease, the retina is actually relocated. You can see the layer, the outermost layer of the eye, which used to call optic nerve head. No, it has been actually detached, changed from their original position. This, the condition which we used to call retinal detachment, right? So this is the eye disease. So why it is happened, how it is happened, that will be discussed further. But which we need to understand what is retinal detachment. Now, the retina is detached from their original position. So what is the effect once it is happened? The retina is detached, then what will happen? Of course, the visual impairment, the particular person will gradually lose their vision if it is not treated timely. Okay, so in this case, the detachment is, uh, very, very emerging kind of eye disease. Even like most of the developing countries also, they have a lot of statistics. The number of patients are keep on, increasing with this, the medical condition. Why it is happen and what is the first symptoms of this particular disease? If you look at, I have given three pictures at the bottom of the slide. Like there are multiple symptoms which we can able to came to know once the disease is occurred. But still, some of the symptoms which we have been given in this slide. So, for example, the first one which you should look at, there are floaters, like, the red, yellow color pouches that has to be, created if you look at any of the object. This is one symptoms which we can see. If it's the numbers are getting more, and of course, your eye is in the not in the normal condition, it is in the abnormal condition. So that you require immediate attention. This is one kind of symptoms. And if you look at the second one, which you can see here, the half of the vision is getting blurred, which you can see here. Because the reason is that the retina is detached. So the remaining portion, like, you will not get the proper vision. Okay, this is also it's also a symptoms which you'll consider, but it is an extreme case of the detachment, you can say. And the third one, which I have been given, a lot of floaters, like you can see here. The generally, if you're not properly sleeping and slept in the night, you will get these floaters. But still, the numbers are more if the eye is abnormal. And apart from that, what else? What the causes, like the particular person which leads to this retinal detachment? Like, of course, the many conditions which include like blood pressures. That is also considered um, one of the cause, and also the extreme, the diabetic level, diabetes mellitus. Right, so it is also another cause of the disease, and also the main thing is that proper, you know the sleep, and the improper sleep, and also pressure, stress, which will many symptoms, like the causes that we can able to define it. So this is what the we can able to understand what is detachment, what is the symptoms of this one, and how it is occurred. Right? A very short, the biomedical perspective of this disease, retinal detachment. Okay, now coming to the statistics, why need a special attention to this disease? Like since it is a the eye disease, and most of them, many of them don't had about this disease. Like we know very common eye disease, but many, the special. If you want to do any research, if you have a special attention, then only you can came to know this particular detachment. Why and what we can do, why it is important, and what the technologies we can do with it. If you look at the statistics, I have given some countries, even the developed countries like US, Netherlands, and the annual incidence is also much higher than for a 1 lakh person. The percentage is from almost 18%, and it leads to 20%. And if you look at the another, some set of countries, England, Denmark, Taiwan, that is also we have a large percentage, 15 to 16 percentage, and also in Asian countries like China, Singapore, even 18. And if you look at the developing countries like India, the cases are almost around 18 percentage of case. Like, if you look at, even in the 1 lakh, the percentage is 18, and in the whole, the populations, the numbers are more. That's why we required a special medical attention for this particular disease. And most importantly, in almost in all the countries, the aged people are getting affected by this disease. You look at the age range is from 55 to 70 years almost. So, once they're reaching into the 50, 55, our human body biologically will get a lot of, uh, impact, and those impact actually creating, yeah, the abnormal symptoms to this particular disease, right? So that's why, we have to take it to special attention for this particular disease. It's not just like, the cataract, glaucoma, and all. Like this is the very dangerous disease. The problem is that if it is a glaucoma, there are the white color bulb that will be creating in the eye, right? So if you apply a laser treatment, then it will be completely cured, the cataract. But if you look at this disease, it's very dangerous. The retina is actually relocated from the original position, right? So that is a very, very uh, dangerous eye disease, which we can say. Right. This slides maybe given you more insights into the retinal detachment. What are the different types of retinal detachment? If you look at the detachment cases, if you look at the first image, it is the a normal image, the first one, which you can say the normal one, because there is no abnormal symptoms actually, which you can able to see this particular first image. This image was captured through fundus camera, which will be available in almost in all the eye hospitals, which you can see here. That's we used to call this is a fundus image, retinal fundus image. And this is one of the two-dimensional image, and most of the researchers, those who want to work, or most of the clinicians which want to screen any eye disease, they will acquire this two-dimensional image from the fundus camera, then they will taken for the screening. So like the whole study, we have also, consider the retinal fundus image for the detection of the diagnosis of the retinal detachment. And the whole detachment, which you can see, there are three types of retinal detachments are available. One which you can see here, the rheumatoneous retinal detachment. What is this rheumatoneous retinal detachment, which you can see here? The rheumatoneous is a very, very common, the retinal detachment, which you can simply call it as RD. And it is a early RD also. The first symptoms of this RD, which occurred in this type, rheumatoneous, right? So, which is called RRD in simple acronym. If you look at the RRD, small lesions that actually created, near the boundaries of the optic nerve head. And this is like one of the treatable stages, we can say. And what happened when it will lead to the other type of retinal detachment, which you can call it as the tractional retinal detachment, TRD. The tractional, sorry, this is not TRD, this D is the TRD. So this is TRD, right? You can see here the most of the portions of the retina, which will be covered by the the whole lesions and also many patches, white color patches. So that will actually impact our vision. And this one, which you can see, it's called ERD, exudative retinal detachment. The whole portion, it is the extreme case. You can see here, the whole portion will lose their vision. Okay, lost their vision. So this is the nature of the whole retinal detachment disease, and also the different types of the detachment. Why I'm explaining this biological background of this retinal detachment is that once you understand this imaging background, then only you can able to do some of the technological innovations. So in this case, so first we need to understand the whole biological physics of this imaging modality. Yes, we have understand different types of retinal detachment and what we are going to do and why we need to discuss all this, the three types of retinal detachment into very deep. The understanding is that, to diagnose this retinal detachment is one of the huge tasks for the medical practitioner because the reason is that the symptoms, like what it is you have been seen in the last slide, it is totally, confusing for the retinal, experts, the ophthalmologists, like eye doctors. And, the only trained or the experienced ophthalmologist only can, categorize which type of detachment and whether it is the detachment or some other eye disease. That is also a major challenge that will be facing by the clinicians. That is why, yeah, manual diagnosis is, like a lot of challenges that will lead to automatic diagnosis. So if you look at the manual diagnosis, there are a lot of problems like, it is a time consuming task, which require a lot of time and we required many, the clinicians and also the supporting staffs, labor insensitive. And of course, it is very, very difficult in a large scale clinical application. Suppose we have, large patients for dealing all these patients with short span of time, it is also very difficult. And also the severity level, what severity level, which we can understanding the severity level is also difficult and it is totally complicated. So that, which will lead to an automatic detection of this particular disease. So look at this case, like, all this, the motivations which we actually, like progressing or which we are contributing towards this retinal detachment disease. If you look at, in 2020, when I was started working this particular retinal detachment disease, there is no publicly available data set. Since if you are the, working with any AI tool, we require a huge amount of data. But if you look at, in the open perspective, there is no publicly available data, which you can directly take and you download it, you can work and we can contribute. Like we do not have any such data set which is available. So that we have thought of, creating a data set is our first thought. So that we have collaborated with four major hospitals in India, and all these hospitals are, supplied a large number of images, retinal detachment images, and we have actually created yeah, our own data set, which is called retinal detachment data set, which is also available in IEEE data board, the screenshot which I have been given. So you can also nowadays you can also download this data set. You can work with any of the AI algorithms. This is our first contribution from this retinal detachment disease. And of course, which we have been closely working with all these four hospitals, doctors, and the medical staffs to come up, to publish this data sets. Okay, now the point of the discussion is that we have a data set, like we have our own data set. Then what we can do with this data set? Of course, which we need to play with many artificial intelligence frameworks. So in this case, what we have been done, the initial part of the work, when in 2020, which we have been created this data set, at that time we have only, the binary class of the data, some set of normal images and some set of abnormal images, and most importantly, the homogeneous retinal detachment disease that we have getting from the hospitals. When day comes and we have collected even the exudative tractional also, but in the initial time frame, we have been working with the binary images, and the later part, we have been working with multiple images, I mean, multi-class images that will also showcase some of the outcome from this talk. If you look at this, the diagnosis part, we have generated training images, which we can say they are RD and healthy. And if you look at the data set, the perspective of how we are classifying, so based on the nature of the image, where we are getting, because the image which you are getting from different sources, right? One is from North India, and another two are from South India, and one is from Northeast. There are different sources of places. So here to make it into the uniform, like we need to play some kind of pre-processing mechanism, and we have done the pre-processing mechanism like resizing and normalization. Then we have make it ready data set that has to be trained for the uh, network. So here what happens is that in this particular case, of course, we have used a typical convolutional neural networks, and the training of this, the whole network from the data, which we have been done with the representation learning. What do you mean by representation learning? So how it will be differ from the normal learning? If you look at the raw data, which you can call any of the architecture, like a pre-trained architecture or any maybe a tailor-made convolutional architecture, that will be directly taken from the raw data that will be extracting the whole, the features. Then finally it will be testing. So here what happened that the representation learning itself given a lot of impact because in our initial days, the number of images are very less, but deep neural networks are data hungry network. It required a huge network images. Then only we'll get the best performance metrics. But in this case, what happens? So we have, for avoiding such, the complexity of, to get the best performance metrics, we have tried many, the mechanisms like, transfer learning, representation learning, different kind of learning mechanisms. But for this work, the representation learning is performing better, so that we have been taken into the account of training the whole data set. Then what happened once the data, the whole detailed layer architecture, which have been given in this flow diagram. Then finally, we are trained the image. Then once the image is trained, then we have tested with the whole trained one for to classify either from RD or the normal class. So in this way, like we have made a very simple tailor-made architecture for classifying the data, two class data. If you look at if you want to reproduce it, maybe such architecture, maybe for not retinal detachment, but also for your work or maybe some other imaging modality, so that the layered architecture will help you, like to how to reproduce such type of algorithms, architecture that you can take into the reference from table. And also, if you look at the training mechanisms and the laws, what which we are getting, ultimately the curve is going to upper. The problem, like when the number of layers and the number of it will be starting from the beginning, then can have some kind of loss. But later, once the network is start, fine tuning, then it will go for a better metric in terms the whole number of layers. So that which we can observe from the two graph which have been given from the slides. Now, if you look at, since which we have been developed a very simple customized network, which is called RLRD net in this work. At the same time, for, to do this, all this comparison and other kind of analysis, we have done the training of the other network also, like Google DNet, Inception, ResNet, some of the pre-trained networks which we have been done. And of course, in all cases, the performance is better than the others. And in terms of computational time, the computational complexity, also the network is better than the others. So that is a whole contribution of this particular network. And most importantly, as I told, like we use the representation learning in this architecture. And the same way, if you use the transfer learning, what is the performance? It is varying. Like that also, which have been compared for this particular study. And mostly in all cases, the representation learning is given a better one. At the same time, if you look at the classification metric, and since it is a classification problem, if you look at the confusion matrix and ROC curve, all are better than the others. So that's way, like this architecture is maybe a unique for this particular data set. So that is our first, the initial contribution in this retinal detachment disease. When the days comes, like, we are also exploring more data and we are getting large data from different sources. And we have a strong research group to work with, to study the different performance measures of, the deep neural network, especially for classification of the RD disease. In this way, what we have done, so we have investigated three fundamental methods. In method one, what we have done, we have selected different deep neural network, and most of them all are pre-trained network in this case, and how the performance which we can obtain. So we just done a performance analysis in one method. And second is that whenever we are doing the performance analysis, the whole part which we can done with only the raw image. We can't we didn't done any kind of the pre-processing mechanisms, how we can evaluate the whole data. So that way, what we have done, we have also done different pre-processing strategies. Which pre-processing, because in image processing, if you look at, there are multiple pre-processing mechanisms we can say. But in this case, like, what are the better pre-processing strategies that we can able to utilize to evaluate the deep architecture, that also we have done in the method 2. And method 3 will also we have investigated in most of the cases which you are working with, many deep learning algorithm. And if you look at why can't you hybridize this model, right? So that also we have investigated. Like, we have used a typical modified VGG19. That's a pre-trained network. We have also used BiLSTM, and the whole combination we have done the hybridized network for the RT classification. Okay, so this way, the whole, the upcoming slides will give you the more insights into how we actually investigated this whole study in different mechanisms. And if you look at the method 1, like, a very simple performance analysis, right? Like, we have utilized many deep architectures, many pre-trained networks. including AlexNet, Inception, many network like say GoogleNet, VGGNet, IntensNet, ResNet 50 and all. And we have the here what we have been done. Initial, as I said, the data set is very low, so we have used the transfer learning to get the better outcome. And once the network is trained, then we are trying to classify with RD and non-RD classes. And here, if you look at the whole the pre-trained network, so we want to intentionally find which pre-trained network is given good results for the study. So we have done a lot of analysis in this, but finally we have got in some very good performance for the ResNet 50 architecture. Why this ResNet 50 architecture is given very good results than others? We have done many other network also, but here we have reported only the best metric what we have been obtained. So the those networks are actually reporting in this table. And if you look at almost the performance, the 97, 98, and finally it is deviating from 98 to 99. Since in medical imaging, achieving 1% of accuracy is very important, milestone, which we can say. So in this case, like the ResNet 50 is obtained a better metric. And if you find the reason why the ResNet 50 is obtained, reasons are many. Like, it is a 50-layer architecture. We have a different convolutional layer and polling layers, the whole thing. And ResNet 50 is having a capable of, extracting a deep features, in any of the data. So the nature of the network is like that. So that way, which you can see, the ResNet 50 is given a good amount of result in this case. In the same way, we have done what happened in 2020, whenever we have started this work. At the same time, the people like, in other countries, like most of them are from, China and Taiwan, they're also actually working with this particular retinal detachment. And they have a different set of images. And also, we have also compared in those case times and which one is better, which one the model is given those things. And in all this case, like we have, like some have, proved the efficient of this whole performance analysis. And if you look at the same way, we need to, uh, discuss with the different confusion matrix and ROC curve to prove the efficient of the classification model. And in that way, the ResNet 50 is performing better than the others. In this understanding, what we have done in the performance analysis case, we have taken only the raw data without any, uh, the pre-processing mechanism that have been done. Then we have a very curiosity, especially have plenty of pre-processing mechanisms, right? And those pre-processing mechanisms, what happens is that which will be helpful in some cases, to fine tune the model and of course to get to yield the more performance metrics. In those cases, we have tried. But in this case, we have plenty of pre-processing mechanisms which have been tried, but out of which very few which we have been listed here. And these pre-processing mechanism will helpful for the effective feature extraction from the data set. And if you look at the name of the data, pre-processing mechanisms are very common to you. Even adaptive histogram equalization, then conversion of RGB to HSV, green channel extraction, red channel extraction. So many, the extractions we have tried, but these two are fundamentally most important, especially based on the nature of the image. And finally, all these will put into the combination of this network, Inception and ResNet V2 version. And this network is predominantly working well. Then, of course, the metric is also a very acceptable range, which we can say. And if you look at, some of the, the pre-processing mechanism, suppose once the input image is like this, then if you apply the different pre-processing strategies, then what happens? We can also understand the imaging background from this second figure. And now, if you look at the whole, again coming into the performance evaluation, and if you look at the different, state of art technique, all type of, the analysis which we have been done in different cases. Yes. This network is pretty good, which we can say. This network, what happens is that, like, we have hybridized this network. How we have been hybridized? So the center portion of this image, which you can say, this one is the deep network here, which we have been used. And here we have, once the network is, completely extracted a feature, and we have used the BioLSTM model, especially, the nature of the BioLSTM architecture. The nature of this BioLSTM architecture is that, is a recurrent neural network. So most of the past features that we also consider into the account. So in that way, we can able to get a good metric in this case. So overall, this network also has applied some kind of pre-processing strategies and augmentation to get more input image in this case. So in that way, if you look at the whole network, this is very unique. And also we have used the different, the wavelet packet and fine tuning mechanisms in between uh, in the part of training and also feature extraction. So this whole network, which will be given us a very good attention to classify this disease. If you look at the table, again, it will help you to reproduce this work, the whole layered architecture which have been given. And also it's a very basic structure of BioLSTM, which will be different from LSTM because how the BioLSTM which will be very in terms of forward layer and also backward layer in most of the cases, which you can see. So in this case, the result is also much better than the others. So you can see in terms of both numerical result as well as the qualitative results in the form of confusion matrix and ROC curve. Okay, so one set of study which we have been done with the different performance measures of this. And in other way, what we have been done is that so when we are developing a deep network, so all this network, whenever you are going to train the model, we have used the manual hyperparameter tuning. Because in machine learning or any AI, the hyperparameter, selection of hyperparameter is more important. That will be, you know, helpful to get more outcome of your network. So in what which we have been done all the preliminary works, so we have manually selected the hyperparameter based on the trial and error or maybe based on our experience. Then what happened when the time to think like why can't you use automatic hyperparameter tuning and instead of manual? That will also given a good impact, especially to train the network. So in this case, what we have been done, we have studied there are two different hyperparameter mechanism. One is the gray wolf optimization algorithm, which we have been tried, especially for hyperparameter tuning. And also, not if you look at the gray wolf optimization, we have a plenty of the optimizations algorithm which are available, the swarm intelligence algorithm, the whole family. And also we have tried the soft computing constituent, the genetic algorithm. Also we have tried in this study how the genetic algorithm maybe we can utilize for the hyperparameter tuning. So, well, taken into the multiple literature and many literature, then finally we came to get a better metric for this type of hyperparameter mechanism. So that we have actually tried in this. If you look at this particular workflow, where we actually done this hyperparameter tuning part. Like we have a typical CNN architecture here that we have been developed, and we have a data ready. And here in the convolutional neural network, whenever we are going to train the network, we actually using all this, the hyperparameter like number of epoch, initial learning rate, final learning rate, all this R2 or regularization function, momentum, multiple functions that will actually doing in manual. But here what happens is that instead of selecting the manual hyperparameter, here we have used the Gray-Wolf optimization algorithm, GWO, for selecting the best metric of this network. What happened? The advantage is that sometimes what happened, if you are selecting the number of epoch is 50, right? Then what happened? The whole system, the whole architecture, it will train the network for the 50 epoch. But sometimes maybe the network may be given best metric given 20th epoch. Who knows, right? Then unnecessarily the network 30 epoch is running, right? So here what happened? The GW will optimize which one may be the better. So in that way, we can get the best performance even a short span of time. So in that way, we can reduce the computational time. Okay, so that is the advantage of this particular architecture which we have been made. And also we have studied multiple evaluation parameter, if it is how the GWO is performing better than the other swarm intelligence algorithm, PSO and whale optimizations and other. So that also we have studied. So predominantly the GWO is performing better in this case. At the same time, if you look at the different results, especially to prove efficient of this model, that also we have done. Like if it is optimized, what will happen? If it is non-optimized, what will happen? And the whole classification metric that we have been done. So in all cases, this one, the GW is performing better than that. And if you look at this table, initially the number of contributors are very, very less. But now if you look at, the people are actually increasing, to work with retinal detachment. But if you look at in the Indian scenario, our research group is actually first effectively contributed in this retinal detachment, especially in the Indian framework. If you look at in all cases, they are producing a better results. And as I said, not only for the SOM-based algorithm, which we can also use with the soft computing constituents. If you use the genetic algorithm, how we can effectively very simple classifications. But here we have used only the deep network only for the feature extraction. So instead of that, we can use a dedicated deep neural network only for feature extraction so that the complete features can extract. Then what happened for classification, we have used the other algorithm, which you can say RVFL classifier, ELM, extreme learning machine classifiers, that we have been hybridized here. And finally, we've taken the majority voting, then we are achieving the classification. So in that way, what happened? We are given the less computation for the deep neural network to extract the complete feature. So in that way, also possibly we can able to increase the classification accuracy in this case. So this network is also a very unique network, which we named this network is called OptiNet. Okay, this is also available publicly. You can try with this network. Suppose if you have a different data set, maybe for some different disease, different modality, you can also try these networks. So this is the whole workflow of this one, like so how augmentation is done, pre-processing has been done in between those things, and how we have actually hybridized this classification, extreme learning machine, and random vector functional link classifier, all the mathematical background which have been given. So you can refer it later on, how this can be utilized for your work. And the same way, like, we have tried many uh, performance-based studies, and it's right from, it's a soft computing constituent. So we have used a different activation function, because the selection of activation function is also a major thread in challenge in this one. So that way we have studied the result with the different activation function, and also we have done the analysis with different optimizers. So Adam, SDGM, stochastic gradient descent, and RMS Pro, different optimizers which are also we have studied. Okay, so this is one part of study which we can say. It's instead of initially we have done performance based study, then we migrated into hyperparameter tuning based study for this. Here, the third part of the discussions comes to is that all this whenever which we are doing in the simulation part or in the the deep neural network part, so all are giving very good results which you can see. But here the problem comes is that whenever which we are developing a medical imaging algorithm, that finally it will lead to into the market, right? So which we need to develop a hardware. So the hardware will be going to serve in any of the hospitals. The clinicians has to start using these trials. So in that case, what happens is that all these networks are very bulky network. And when you are going for the real time, the telemedicine applications, it's very complex to get the decision in a short span of time. So that way to get, I mean, in this motivation, we are trying to use the lightweight convolutional neural network, especially for retinal detachment. Main applications to develop a prototype and hardware, and especially for the use of telemedicine application. So in that way, what happened? So we have developed two lightweight network. The initial part of the study, which we have been developed, light RDNet, RD LightNet. This is for the two class which we have been developed. We just want to try the output. And the second method, which we have named Light MGNet, this is for the multi-class, the four class which we study, which have been done. And these lightweight networks are, pretty good. And of course, this will help us to make a prototype further. If you look at this one, the lightweight network, the two class classification, if you look at the whole metric, it will be very, very good, and in terms of this classification. And moreover, when we actually want to develop a lightweight network, we want to, compare our result with a very popular lightweight network, which is called mobile net, right? V2, V3 also there, mobile net, which are also compared with mobile net. But in this case, the results are pretty good. And if you look at the whole, the study performance and everything, in this case, our network is better in the lightweight. And the second one is that, as I told you, the light MGNet, it is a multi-class network. Okay, so this multi-class network is also a unique architecture. So what we have actually learned from the whole performance study before, that actually will import or integrate in this particular model. So in some study which we have been done the pre-processing strategies, and here we have used some sort of very good pre-processing strategy to get the best lightweight network. And in that way, the typical network which will also use the hyperparameter tuning, gray wolf optimization also, which we have been used to get the the better hyperparameter. Then finally, which you can see here, this particular network will address a four class problem I start from the normal and tractional, exudative, and remoteness, all these cases. And this architecture is also pretty good. And this is also the first multi-class classification work which have been published in the whole research framework. And it is published in the Nature Scientific Report, which you can also refer this paper if you want to take it further. And in this case, we have also used some different online data set. If you look at when we have started 2020, we do not have any publicly available data. And now what happened, people are working and like us, the many people are actually contributing the data publicly. So in that way, this, we have also tried with other publicly available data set, retinal image bank, cataract image data, Kaggle, some different sources also. And, if you look at the whole, different optimization analysis and different classification analysis which have been supplied to prove the efficient of this model. Okay, so now what happens is that, as I told you, like, the deep network will be given, the very higher end network, like a high network, it can't helpful for the prototype development. Then we are intentionally like, want we have developed a lightweight network, especially for the prototype development. But what happens is that now the deep learning technologies are actually slowly outdating. Like, now the new technology actually coming into the picture, especially for the medical diagnosis. Which one among is very popular, the AI technology, which you can call graph neural network. We used to call GNN. And also, which you can see here, XAI, that's also a popular technology, explainable artificial intelligence. And also, which you can see the generative, AI, Gen AI, it is also another popular technology, which, parallelly also, the developing that technology can also utilized for this type of diagnosis. And, most recently, the quantum algorithms, the quantum technology is also actually, developing a very fast. We can also use to, all these computational complexity issues that we can address with the quantum mechanisms. So like different technologies also are growing. But now it is coming into integrate this one, like especially for hardware development. And when we use the deep network, we have tried and implemented, but we have succeeded. But the problem comes into that the timing. The hardware is taking a lot of time to get into the decision. So we have intentionally again motivated how we have to get this, the decision in a fraction of time. So then we have depend with the other technology in AI, which is called graph neural network. So what happens is that in the graph neural network, and here we have tried with the same way how the graph will be helpful to extract the feature in binary class, in multi-class, all these things which you have been done. And also finally, we have integrated this one with the Raspberry Pi model, the embedded model, to make it as a prototype. So in this case, what happens? So we have used the graph network, especially if you look at the whole data. And here, uh, instead of using a CNN in the traditional mechanism of feature extraction, so here the GNN, like, will extract the features like, the node, vertex, and other graph properties. The whole graph set which have been used in this study. And finally, we have used the different extraction mechanisms. Then finally, we can able to classify from the normal classes to abnormal classes. So what this particular methodology is given us, we can able to do with graph studies or graph neural network for the classification. In the same way, we have also done I will come to this one, this architecture for the multi-class, which you can say. But still, we have done a lot of things. This graph neural network. Let me come from this one, the first study. The first study, um, the problem comes into the initial time. The image is the two-dimensional picture, and when you are going to use the graph neural network, like conversion of image into graph, it is a big challenge for us. So then what happens is that, so to avoid such, complexity, the input image that will use the, the simple linear iterative clustering, SLIC, to cluster it. And finally, this clustering will help you to get the superpixel map. And this superpixel map will get into encoding. Then finally, this will help you in the, as the extractor feature. So in that way, if you look at the another few samples of RD image, once you are applying the clustering mechanism, how the nature of the image is getting changed. So this is the initial, part of challenge which you have faced, and we have obtained this type of clustering mechanism. All this mathematical background which have been given, for the better understanding, you can read later. And once this, the superpixel is generated, then we have converted into graph. Then this graph have a different property, as you know, and adding node vertex and all these, the possible, the edges and adjacents, everything which have been extracted from the network. Then finally we'll get the trained model. Then the model is trained, we can test with the different images. And if you look at the even for a simple class also, will get the result in a fraction of second. So that way we do not require any bulky network like deep neural network, is one advantage. And the other advantage is that, like we do not require huge amount of data, because deep neural network require huge amount of data. But if you look at in this case, the graph neural network, it will perform well even a small samples. Like, so that way what happen will help to get into the real time implementation of these cases. So that is motivation behind, and you can see here a lot of things, the comparison class wise and performance wise, and different GNN model studies also we have done. And in this case, if you look at the different graph neural network, like say graph sage, and GN, all these put together, different results came to this one. But the problem comes into this network is that even the binary, if you look at the metric, the performance is only, we reached only 92 point, around 93%. Remaining 7% is actually the loss. So that we need to address it effectively, because in medical imaging background, so that if the performance is more than 99, so that we can go for the hardware development that we have been done. And simultaneously, like we have also done, for this case, you can have a quick glance of this video. We have developed even the mobile app. Also, that mobile app will helpful for the medical practitioners to get the results in a short span of time. You can see here whether it is a detached one or it is a non-detached one. So that initial uh, web application, that also actually we have done it for this study. Then to make it tailor-made, the prototype development. So we have tried not only real-time data what we have also tried with online data also, and also we have done with the multi-class and this architecture. And if you look at this architecture, while looking it is very big, but it's very simple, which you can see here. And the previous one, which we can use only a graph convolutional neural network, which I have used. But to get more better metric, we have also used some other network, which is called graph sage and also GAT. And this architecture, which have been given a ensemble network, and the initial stage is also same what we have been used in the previous study. And once the ensemble network is coming, developed, then we have used the majority ensemble voting then to get the best metric of this. And so what happens is that we are getting a multiple uh, the multi-class data, and also even the graph network, the number of images are less, and the network is also a simple network. So we can try for the prototype hardware development that we have done in this one. So this whole architecture we have integrated with this model, which you can see here. The same model, what we have been explained, so that we have been used to this study. And we have a fundus camera in our lab. So the fundus camera is integrated with the Raspberry Pi for acquiring the retinal image. And of course, this Raspberry Pi is also a small microcomputer. We can do with any sort of computation. And even the advantage of Raspberry Pi is that the Raspberry Pi and OS itself, it is having a Python PyTorch library inbuilt, so that simulating anything, it is very, very simple. So what we have been done, we have also done with the Raspberry Pi display, which is also available, that we can integrate, so we can develop the front end model in the display itself, and so that it will be helpful for the development of dedicated hardware. We can see here, this is a simple experimental setup in this case. And the Raspberry Pi is inside in this case, and this is the display. And we have a simple keyboard mouse. And like we can also integrate the fundus camera with the Pi. And we have developed a graphical user interface. We can able to see this one. And in this case, which you can use to test any model or anything, which you can see here, like, this one is a graphical user interface to helpful to like to get the output in a fraction of second, which you can see. Okay, so this is the whole study. This work is also patented, and you can also try the similar type of experimental studies for your work. And also, to coming to the end of this talk, the whole framework what we have developed, almost all our classification framework. So, being an imaging scholar, we have also worked with segmentation and visualization of the retinal detachment lesions. How your medical practitioner able to locate the particular portions where actually the detachment is affected. So that also actually we have done in these studies. So we have developed our own segmentation framework, and in the part of visualization, we have used the virtual reality tools like to get to more insights into the image. So where actually the portion has been affected, then finally the ophthalmologist will get the clear, insights into the retinal lesions. Okay, this is also the architecture which have been used, and what the framework is actually given. All these things which have been given, or maybe in the framework you can also learn or study this, the paper, so that you can also get such type of work. Also, you can also able to do for your own studies. Now, concluding this whole talk is that, so like the whole work, what we have been presented, it is start from creating a benchmark data set in retinal detachment. And also we have used the representation learning framework in machine learning, and also subsequently we have used the different deep learning architectures for classifying the retinal detachment disease. And not only for the neural learning, but also we have we have discussed the different lightweight architectures for the diagnosis. And most importantly, in apart from the deep learning, we have also discussed how the graph neural network is actually given an impact for real-time studies. And finally, not only a classification, but also we can use the segmentation algorithm and the visualization algorithm to get more in understanding in the particular for the medical practitioners to get more insights into the disease, or we can say the image. So this is the conclusions, and these are all the outcome what we have been actually achieved from this whole 6 years works which we have been done. And this acknowledgement, I think this two project actually given the funding to carry out all these outcome. Two consecutive projects. One is given by DST and another one is from Dristy CBS Foundation, IIT Indore. All these outcomes, and they are our duty to acknowledge these two funding agents. And these are all my, the scholar and the doctors, those who are helping us, and also different collaborator to to helpful to develop such a unique algorithm, and also the hospitals, those who are help to share the data for the studies. And of course, we are open to all. And if you want to, you can feel free to collaborate us, and you can also write any postdoc, or if you want any PhD, or if you want to do internships, you can feel free to write to my mail, and also the whole contact is also available in my web page. You can feel free to connect anytime. So we can. Today you are the audience, maybe tomorrow you may be my collaborator. And these are all the some of the references which have been used for the study. And thank you. And finally, we are here actually, the day of Kartigai Deepam, and still, most of the homemakers are actually doing this Kartigai Deepam in this home. But today we want to learn something, and for me, I want to deliver something so that we have gathered in this day. So happy Kartigai Deepam to all of you, all the participants. Finally, if you have any queries or any questions, I'm happy to answer.
Thank you, sir. Dear participant, if you have any questions or doubts, kindly unmute yourself, ask the resource person. Dear
Yeah,
participant,
good evening, sir.
Yeah, madam, good evening.
Yeah, myself Muthulakshmi, sir, from Sastra University. So I'm a research scholar. I'm doing research in IOMT based domain, sir. So what
Okay.
is my question is intrusion detection system is there. So how we can protect the IOMT based devices, different form of attacks in in the domain of cyber security. Can you explain, sir?
Actually, ma'am, your voice is interrupting. Someone is actually speaking in between. Can you repeat your question?
Yeah, yes, sir. Actually, my research is in the domain of IOMT. So I'm doing with the combination of cyber attacks. So we have different types of intrusion detections are there. For example, man in the middle attack and then a DDoS attacks are there. So which attack are the most vulnerable one and which we have to focus, and either we can use machine learning or deep learning, or we can use the hybrid model. So will you suggest anything? Anything, sir?
Okay. To be very frank, actually, I do not have any experience with this type of cyber attack in my
Okay.
research. I never worked with this type of IOMT framework, especially what you have been described. And if you have any questions, maybe related to imaging, or maybe related to deep learning, or something else, so I can happy to answer.
Yeah. Okay.
Hello.
Thank you, sir.
Yeah. Hello.
Yeah.
Yeah. Yes,
Yeah.
ma'am.
Sir, you have shown in one of the slide transfer learning model.
Mm.
So, can this transfer learning model be applied for EEG signal analysis?
Yes, you can.
Okay.
You can.
Can
You
you
can.
elaborate a little
I'm
bit on
coming to
how you
yes.
have used transfer
I'm
learning
coming to
model?
that point. I'm coming to that point. And see, we have used transfer learning because in our initial time, we have less amount of data. That is the only one thing. And now, as you explained, like, you are using EEG data, right? Yes. So EEG data for what? I mean, application which you are going to use, ma'am. May I know?
It is for prediction of uh, prediction of different kind of disorders.
No, if you look at the EEG data, like,
Mm-hmm.
whenever you are going to acquire the EEG data from the EEG machine, so
Right.
which we need to have a different electrode mechanism.
Yes.
And,
Yes.
this whole electrode mechanism, say, for example, if you want to go for emotion detection, so you need to collect the data based on emotions of the human.
Right.
Suppose if you
So
want to,
I'm
like,
working specifically on epilepsy.
yes, that,
Yeah.
that your application is, epileptic seizures, then here the point is coming, it is that we have a well-defined data set for epileptic seizures for, University Bern.
Yes.
Okay. So it is a universally accepted data. And if you use those data, because this EEG data is generally a one-dimensional data, like it is a well-defined data. Okay. So in other input is also I'm trying to give. There is the other data set which is also launched by IIT Delhi. Okay, so that is also publicly available in IIT Delhi Department of Electrical Engineering. Professor Tapan Kumar Gandhi is contributed this data set publicly. Okay,
Okay.
so you have enough number of data, especially for epilepsy seizure detection. Okay, once the number of data is huge and you no need to think about the transfer learning mechanism, then how we actually want to do the
No, the
thing
EEG
better.
signals, are different for different humans. So most of the predictions or any work which is done, it is more on personalized level. So if we want to work on kind of prediction, where one data set will be helpful for predicting for another set of people, that is what we are trying to do. So will
No,
that
that
be
that may be
possible?
your problem
Hmm.
statement. That may be your
Hmm.
problem statement is different. I'm trying to answer for your first question.
Yeah, yeah, yeah.
Okay, so when you are going to detect the epileptic seizure, while asking why can't I mean your question is the transfer learning. You can use the
Yes.
transfer learning. It is depends on the data. But what I want to answer is that you have enough number of data for seizure. Okay. So instead
Hmm.
of using a transfer learning, you can try to focus to develop a better network or a better model. So that will actually give a lot of impact in terms of novelty.
Okay. Thank you. Yeah.
Good evening, sir.
Yes, madam. Good evening.
Sir, which feature which used for creating that GNNs? No?
Okay.
How did you identify?
Okay. Okay. So here, again, if you look at the features, it is, of course, it is depends on the data. But here in our retinal detachment data, all these data are actually statistical features. Because the whole features in terms of the lesions, like, so if you're talking about the lesions, so every part of the the retinal image, so that we are taking into the statistical mechanism. So here in our all our studies, so we have considered the statistical features, then those features actually feed into the graph neural network that will helpful to extract in the form of node, vertex, and all sort of graph properties.
So statistical features in the sense their brightness and their.
No, no. It is not color based. Statistical feature means that a typical retinal image, we have a different, the name of the lesions. The lesions names, which is called actually microaneurysms, exudate, cotton wool spots. There are different, the features. It is the exclusively lesion based feature for retinal image. So in a typical imaging, you may heard about, area, perimeter, but this is the biological features.
Biological features which are quantitative.
It is quantitative and also it is qualitative.
Qualitative also.
Yes.
And data set was available, sir?
It is available. I have shown, no? It is available in IEEE data port. We have also launched a data. And there are multiple, data set is also available nowadays, even in Gaggle, retinal imaging bank, different data set is also available.
Sir, and one more thing is there is a possibility that photographic images can be converted and embedded in a CT scan image. I mean, convert it to a grayscale and embed in a CT scan. Is there is a possibility?
Now, what device which you want to acquire? Like from
No, I
mobile or some other?
of something, some lesson or something, and I want to convert it into a CT scan and manually generate that lesson inside any CT image. Is that possible?
It is not at all possible because the reason is that why we go for the CT? The CT machine is generally a layer architecture, right? We have a different layer. With the layer only actually which we are acquiring the image from the image, main lobe, side lobe, the different lobe mechanism that will helpful to to understand the different the parts and the lesions which is present in the image. And if you want to convert from maybe from this image into the some other image, or if you want to translate from this image into some other image, then what happen? The originality of the image will have a chance of loss. Then again, if it is going for further processing, it will be quite challenge. I mean, what you want to do to the image. It is very pretty, I mean, challenging task. But people are talking about this translation, but the please, audience, please mute yourself. And the people are talking about image level translations, and we are working. But if you look at in terms of the extraction from the transferred image, it's very challenge to to get more feature. That is from my experience I can share with you.
I have an idea of just an organ without any lesson, and I want to embed a lesson picture which is separately there into that non-lesson CT scan. This was my idea. I don't know whether it's possible, so that's why I asked.
No, you can try with these studies, like like converting from this one and the other different mechanisms. These are all like the different ideas that comes from the technologies like us. But when which you are going to for the clinical trial, like that we need to see the feasibility, the pilot study. So today, if you are proposing, then it is working better. Who knows? Maybe 10 years after, this methodology may be also popular if you are getting a proper output and if you are supplying a proper, the
I don't know
clinical
whether
framework.
it's possible. I don't know which technology to use. Any ideas, sir?
No,
Which?
technology, it is, I told basically you are talking about image to image translation, right?
Yes, sir.
So here the technology which will predominantly used like, the generative adversarial network, it is most widely used in the recent time. And also in technology wise, the transformer networks, that is also working pretty good for image level translation. So either this one, two, or maybe you can club with the GAN with the transformer network and you can hybridize. In that way, also this technology may be helpful for this type of applications.
Thank you, sir. Thank you for your valuable input.
Thank you very much, sir, for
Yeah,
your informative session on the AI in medical imaging, especially in retinal imaging. Thank you very much, sir.
yeah. Thank you, sir.
Thank you, sir.
Recording stopped.
Hello, sir.
Sir, Manimaran, sir, welcome you, sir.
Thank you, sir. Sir, am I
Uh,
audible?
yes, sir, audible, sir. Just
Video,
sir.
I think it should be possible now.
Yes, sir, your video is visible, sir.
Yes.
Just one formal intro about you, sir.
Yes, sir.
Good, thank you.
Very good evening, all.
Sir, shall I turn off cam?
Sir, what, sir?
Shall I turn off camera?
Okay, sir. After your presentation, you
Fine, thanks.
can start 5 minutes, sir.
Okay.
You can
Okay.
switch on your camera for 5 minutes for screenshot purpose.
Okay.
Now, no need, sir.
Once again, great evening to all gathered here, and I welcome you all for this adult sponsor 6 days online FTP on next generation medical automation, the role of AI and IOMT in transforming healthcare systems.
Recording in progress.
It's my pleasure to welcome our today's resource person, Mr. A. Manimoran, Assistant Manager, BI Solutions, Bangalore. Welcome you, sir.
Sir,
Yes, sir. Before letting into a session, we may see the short intro about our guest. Mr. Manimaran graduated as Bachelor of Engineering in Electronics and Communication Engineer from Anna University, Chennai. Currently, he is designated as an Assistant Manager in VI Solutions, Bangalore, and handling the major responsibilities of supporting various industries in implementing a several turnkey systems and system integration projects using NI products. He is also handling the major responsibility of improving the quality of engineering and science education and eradicating the improved methods of education and including the interest of lab use. Mr. Manimaran has traveled far and wide throughout India and Sri Lanka, has delivered through provoking lectures which inspire the students and kindle their interest towards lab view and also visited more than 200 Indian engineering institutions. He had conducted more than N number of hands-on training to engineering students of various branches on LabVIEW basics and data acquisition. He also had conducted more faculty development workshops on various trending technologies, including RF communication, wireless systems, advanced signal processing, data acquisitions, and control. He delivered more than 350 lectures on the topic of experimental engineering education on various technology topics. His key interest areas includes RF communication and wireless system, measurement and automation, sensor, data acquisition and signal conditioning, wireless sensor network, and FPGA. He is also a certified LabVIEW developer from National Instruments. I hope this session is going to be a grateful session for us, and I wish to hand over the session to our resource person, Mr. A. Manimaran, sir. Please, sir.
thank you, sir. Excuse me.
Yes.
Uh, Sir, is it visible?
Yes, sir, it's visible.
Okay, great.
Yes, sir.
Uh, so, very, I think, hope it would be on a full screen now. Yes,
Yes, sir.
great.
Yeah.
Thank you, sir.
Yeah.
Very good evening to everyone. I hope it is very late for the session and the attendance also very good. So thanks for everyone for sparing a time over here. Uh, okay, 1 minute, 1 minute. So, sir, is it visible?
Yes, sir, visible.
Okay, fine.
Yeah.
So, very good evening to everyone, and thanks for the opportunity here. And today we are going to see about how NI technology will be useful for biomedical related applications, how LabVIEW can be used for it, what are the different kinds of NI DAC cuts that we can make use of it, what are the different imaging techniques that will help us in using different AI models, or how exactly IoT and importance of 5G network for doing real-time data sharing, how it can be useful. Everything we can see over the sessions in this. So before I just start with, I just want to give you an introduction about NA technology. How exactly NA technology will help us in understanding the data acquisition process, either in terms of imaging or either in terms of signal processing part. So how exactly we can work with it? See, for example, I want to introduce you a LabVIEW software. So I hope most of the professors who are all present in this today's session would be aware of LabVIEW. If not, LabVIEW is also a simple programming language as similar as your C, C++, Java, MATLAB, or Python, any of your application building product plan. This is what LabVIEW is. So with the help of LabVIEW, you can develop your own logics, algorithms you can implement over there. So how exactly you do with MATLAB Simulink, the same way you can build programs and applications over there with LabVIEW. And why LabVIEW is very much advantage in using is uh, because it is very much a graphical way of programming, and which will support desktop platform. Either it will be in a form of Windows or a Mac, you can use it, or any real-time FPGAs or RT processor, you can make use of it. And additional to it, if you want to work with on an AT system or application developments there, it may not be only NA hardwares will be available everywhere. So there will be a totally different make, different companies products will be available. For example, NI technology will be used in Yokogawa. NI technology can be used in Ferrari. NI technology can be used in GE. NI technology can be used in NASA, Boeing. See, the basic part is something as a data acquisition process. Anywhere I can get information as a data, I can make use of NI platforms here. So I have several platforms, something called as LabVIEW as a programming platform. I have a test stand platforms. I have something called as Diadem for big data analysis. And I have a variety of NI data acquisition systems for acquiring data. Most of you would have heard about biomedical sensors from Vernier or iWorks or different companies who's making this different kinds of sensors. That also can be easily integrated with your NI modules over here. Sir, can I mute my cam? Is it okay? So most of the times, if you see, NI data acquisition will be preferred for any kind of system integration process. The reason is NI can be used with seamlessly with third-party modules as well. For example, if I have any imaging devices, I can integrate with it. It can be a cam, or it can be a scanner, or it can be a printer. So I can easily communicate to them in form of USB or Ethernet, or any terms I can try to work with it. So that's the reason, if you see here, whether it is a car manufacturer, or it is a missile manufacturer, or it is a aeroplane manufacturer, they all will be using many vibration based devices, acquisition of different parameters they'll be doing during their model testing and other. For that, they'll use NI hardware, as well as other third party hardwares also will be available. So non NI as well. So it will be much easy to integrate it together by using a single programming platform, which is LabVIEW. So that is the advantage of going with LabVIEW. If I go with a different programming hardware or a software over there, for example, today if I have a hardware with NI, I'll be using NI software. If I buy some other microcontroller, they will give one data logger. I have to use that particular software. For image analysis, I'll be using Python, or I'll be using some other online tools, or even MATLAB I'll use. For example, if you see, I have to go with different toolkits and modules which I have to add. So in case of it, I can use a single LabVIEW as a platform. How exactly in MATLAB you have a different tool sets you have. Similarly in LabVIEW also I have lots of tools and modules I have with it. With the help of it, I can easily work. So if you see over there here, we have something called as GE. We have General Electric. Many of you are aware of it. So they not only provide general equipments, they'll also provide medical equipments also, they will do it. Whether it can be an X-ray machine or CT machines, which you can easily do with it, or in simple terms, if I don't have any parameter or any hardware can be used for it, what I'll be doing is I'll simply take images from the lab. I'll try to do the post processing using LabVIEW. Of any other algorithms, if I have, I'll try to use with it. So this is how I can easily make use of LabVIEW for it. So how exactly LabVIEW you can use for it, or programming part is. So this is how we will be writing programs in LabVIEW. See, for example, if you see here, we use C code or Java code or Python as a lines by line text based program. Whereas in LabVIEW, we will be using block by block, icons by icons, we will be using with this. To perform the same addition operation, or to doing the image correlation operations or filtering operations, we'll be taking in form of an array, and we'll be working with it. So this would be the difference between normal text-based programming and LabVIEW programming. So whatever I develop with LabVIEW, everything will be in a form of graphical. I will not program anything in form of a text-based over there. Still, LabVIEW will support text-based. For example, if I have a MATLAB code, so what I can do it is I can directly copy that MATLAB code or script into LabVIEW, and I can directly work with it. Excuse me. Even if I text-based any algorithms, if I have also, I can still make use of that. As a text-based program, I can take a logical and I can implement with that. And if any programs you want to develop, so you will be having something as a block diagram for your backend, and you have something called as a front panel. So front panel will be the place where we will be using controls and indicators for your applications. So whatever we develop over here as a program, everything will be having controls and indicators, where all the controls are called as inputs, all the indicators are called as outputs. Excuse me. So if I develop something over there as a virtual instrument, whatever I'll be using it as a device, as a real hardware, the same thing I can use it with a minimal DAC card. Along with it, I can build my own GUI panel for it. For example, if I have something as an imaging device, for that imaging device, I can create my own GUI so that it will be much useful for me to work on it. So all are custom programming here, which will allow you to do any kind of coding, any kind of signal processing or image processing or any filter analysis if you want to develop. Yes, you can build through using LabVIEW. So here, I just want to give you different options over there. So in a very simple form, if I work with any of the options here, for normal scalars will be numbers. How exactly we have seen over here. If you see that I'm just performing some simple addition subtractions I'll do here. But excuse me, if I work on something as a ECG signal or EEG signal or EMG signals, if any goes for a signal wise, I'll be going with a 1D array of data. So LabVIEW not only supports scalar, it also supports an array of information there. The same thing if I work on images, it will be a 2D array of data. So I can work more than 2 dimensions also in LabVIEW over there. I can work on multiple frame by frame of analysis also. I can do with 3D images also. I can do with LabVIEW. So these are all different programming methods, error identifications there. But I just want to show you simple environment wise how LabVIEW will look like. I just run through basic slides so that you will understand. So this programming platform also will help you in building up all your logics or doing your analysis part. So here also we have different case structures on a conditional basis. If you want to perform any logical operations, yes, you can do with that. I have different looping structures also. I have a while loop and for loop over there in it. So how many number of iterations you want to run for your images, multiple filterings you want to apply for it. You want to run the image for 2 times, 3 times. You want to do that entire filtering process. All those things you can, yes, you can do with this. With this, I just want to give you a feel about how LabVIEW is different from programming, but what are all the similar features you have in other programming languages? Yes, you have over here. Still, you will be able to use with it. And if you want to connect with different logicals buildings over there, yes, you can still able to do that. Yes. So you have shift register options, and I'll quickly go for arrays concepts. Similar, you can work with multiple dimensions. Yes, you can use it. And we have an option called as uh, file IOs. So different graphs and charts options also you have, where you can plot your own custom datas. You can plot it. Arbitrary waveforms, yes, you can develop. We have a XY graphs as well. So if you want to plot on a combination of X and Y coordinates, yes, still we'll be able to plot them. And we have strings and file IOs over there. So what are all the any communications to any third-party devices or non-NA devices? If you want to communicate, yes, you can communicate via LabVIEW by sending the commands. And if you want to do the data logging options with that, yes, you can use with this file IO operations. If you want to do the post processing after acquisition, yes, you can read from the files option over there. So we have a file in, file out options over there, which will allow us to read from the different files over there in it. So you can have your own combinations and you can work with it. So what are all the basic operations that you are able to do with other programming software? Yes, I also can do that with LabVIEW here. Yes. So this is just an overview introduction about LabVIEW over there. So we have different options there. You can save it in a form of LabVIEW measurement file. Excuse me. You can save it in a form of a binary file. You can save it in a form of TDMS. You can save it in a form of I can say it's a CSV or tab delimited. Different options. Yes, you have with this.
Manimaran sir, PPT is not visible, sir.
I think my audio. Yeah.
Yes, the audio is okay, sir. But
Yeah.
slide presentation is not.
Yes. I am changing a different slide.
Okay,
For
sir. Thank you.
RF related, I just want to start now.
Okay, sir. Okay.
So how exactly 5G options do we have here? How exactly we have different other modules we have? I just wanted to show. Excuse me. We have some items on RF also. So again, these RF modules can be programmed using LabVIEW. So if you see, we have a USRP module, which is a SDR hardware, the software defined radio platform. So how exactly the software defined radio platform will help us? This particular module has a transmitter and receiver in this single hardware itself. So if you want to transmit and receive within a particular local area network, if you want to push this hardware to it, yes, this will help you with this on a particular RF. This will not work on Wi-Fi. This is a pure RF transmitter and receiver. So you can have your scan data or your any of your eye cataract images or your ECG data. If you want to transmit from one end to the other, you can transmit these informations with this. Along with we have another hardware called as MyRio. Uh, 1 minute. Yes. I'll just share. I'm just sharing the entire screen so that I can showcase you different options. So if you see here, this is one hardware which is an Elvis. Most of you would have seen this or heard about it. This is one data acquisition device where exactly what you can do it is you have a breadboard where you can connect different sensors. I have analog in, analog out, you can work on it. So where you can acquire data from a different sensors based, yes, you can use. And I have another hardware. So I have another hardware called as MyDAC. So this is also has a analog in, analog out. Do you see audio in, audio out you have? So if you want to acquire any data over there, yes, still you're able to do. This is a 16-bit device, 200 kilo samples where you can acquire over there. So similar hardware, we have it in a form of Myrio, which has an embedded platform in it, which has an FPGA in it over there. So these all for students where they can use with different options. And this particular hardware has a Wi-Fi in it, includes an onboard Wi-Fi over there. For example, if you are working over there in a uh, hospital, I'm trying to doing some work. For example, I'm there in an operation theater. So where I have to get the informations over there. So I'm just taking a X-ray in it, or I'm just want to have some informations, want to access for it. So if I want to consult with, or if I want to do communication over there. So if you connect with these kind of devices, yes, you're still able to do with it because it has an FPGA in it. I have a hardware which has an RF in it where I can seamlessly broadcast the information to different devices, or I can make use of this kind of hardware, Myrio based hardware, where it has a RT in it, FPGA in it, so it will act as a standalone devices where I can connect different sensors. I have analog in, analog out, different protocol based sensors I have, and I have a USB port also here where I can connect a USB camera and I can work with it. So for a student level projects, if they want to start with it, yes, you can use with it. And in a real time, whatever the missions we are going to use, whether it is GE or BPL, or whether it is what to say, Philips, or different parameters, if you want to take it from a make of a sensor, you can still able to be a part of a network over there in it, because this devices also has a Wi-Fi in it, so which can be in your hospital network, or I can host a network if I am there in it, or if I am there at somewhere. Sorry. So where I have a different hardware over there, which can transmit and receive my data on my own different modulation schemes I can apply and I can take it over here. So, however, I want to work on different platforms. I have a different modules I can work on it. This is just a simple hardware which will work only up to 2.2 gigahertz. I have a module which will work from 10 megahertz to 8 gigahertz. It will work over there. 7, 8 gigahertz also we have modules which will work. Excuse me. So whether you work on a MIMO or you work on a 5G test beds on a different applications, if you want to keep over there, you can use. See, when you want to work on an IoT based applications, you need to have a devices which should be capable of getting into an existing network, or it should be in a position of creating your own network over there. So this device does not have a Wi-Fi, so you can connect this device to your PC, and your PC can connect it to your campus Wi-Fi, so you will be into a network. Whereas this hardware has a onboard Wi-Fi in it, so that if you want to host any network, you can host a network in it, and still it will have a inbuilt controller in it. So we don't want to give any computer to be there associated with it 24 bar 7. No. Only thing is we need to give a 12-volt power supply for this, so it will work over there with that. So that we can directly take multiple modules, you can connect together, and you'll still able to work everything in a single programming platform, which is LabVIEW. So this is what I was mentioning about. So now I have shown you hardware 1, I have shown you hardware 2. Now hardware 3, or one more image I have shown you over there. This hardware also where you can connect and you can work. So multiple devices you can integrate together, and you can still able to collect different sensors informations, image informations, and you can process them. If you want to publish or broadcast over there, you still will be able to do. And one simple information about your sensors part is, I just want to show you a real time what are the different kinds of sensors we can go with this. So this is a US based company, Vernier. So this Verniers, we have a different kinds of sensors which you can integrate with NI LabVIEW, and you can program over there. It is very simple. You can directly plug and play type. You will have a options. They have their own software for it, for analyzing data, acquiring to it. And these DAC cards are provided by NI directly for them. And still, if you want to connect through wireless sensors, yes, you can go with wireless sensors. Each sensor you will get with the wireless in it. So I'll just show you a few products and sensors over there in it. Simple. These sensors will have a plus 5 volt input to it, and you can easily take an ECG from there, and ECG easily you can work with that. So EKG sensors. So do you see over there? This is direct EKG sensor. This is one simple sensor. Yes. Sorry. Open image in new tab so that you can see things properly. So if you see over there, you can directly acquire ECGs over there in it. If you want to get different values of options also, still you will be able to measure them. So if you see over there, you have a 3 leads over there. So easily you can form a interval triangle, and from there you can collect your ECG with that, and you can do. This is for simple student classroom lab applications. If you want to do a real-time data acquisition also, yes, I have a DAC devices where you can connect 6 leads, 8, 9 leads, 12 leads. You can connect and you can acquire data through this. So I have so many number of analog in, analog outs over there where I can continuously collect multiple number of acquisitions over here. So any kind of modules, if I want to take, I can go with this. This particular hardware not only show this particular modules, not only have only ECG, this particular sensors we can connect through different sensor modules we have. For example, we have something called as pressure sensors, BP. Uh, excuse me. So this hand dynamometers, heart rate sensor, EKG sensor, and we have something called as blood pressure sensor. So these are all, if you see there, the connected type, whatever we see here, is all unique. In the previous one also we have seen the same kind of connectors. Here also we have the same. Here also we have the same. So if you have this heart rate monitor over there, you will be getting a peak for every of your heartbeats over there. You can measure the BPMs over there with that. So this is heart dynamometer also comes with the same kind of connector. So you can check what is the strength, muscular activity, what is the grip strengths you have over there. So how you can pinch in it and how you can take the data out of it. So you can easily analyze them there. Yes. So I got few chats. Excuse me. Yes. Still no audio?
So your voice is audible, sir. That is,
Okay.
they posted 10 minutes before, sir.
Okay, fine. So this is one company which is giving you different options of different sensors you have. See, anything you have a plus minus wire, any sensor if you take from there, yes, you can directly connect with any DAC based modules and you can acquire. Even to a certain extent, you can use Arduinos as well. So you can integrate with LabVIEW and you can work. So I have another tab where I have different options there. There is another sensor called as iWorks. So we have something called as NI compactable kit from here. Biomedical related kits we have there. So directly these modules it will go as a plug and play options over there for it. So do you see over there MyDAC and Elvis hardware sensor packages? So you'll get these modules over there. So directly you can integrate with these options there. Excuse me. So I'll just open this with breadboard, basic breadboards you can directly connect. So these are all sensor packages which are there available for any of your direct options you can have in it. So if you see here, this particular connector is very much equivalent for this hardware connector. So in place of this, we will be connecting our sensor module connector, and each and every sensor you can plug into these two BNC terminals or these terminals what you have, sensor connected terminals. So do you see there here also you have a BPM options, you have a pressure BP options, you have a heart rate monitors, you have ECG sensors, you have respirometers, so you have a pulse sensor. So similar kind of different modules which you can include in your package and you can work. So these are all some data which you can transmit through wirelessly also. Still you'll be able to transmit data over there. Still you can take, so you can connect microphones also with the audio lines over there. So you can take what is the respiratory sounds you have or beats different things which you want to collect, you can collect over there. So different varieties of products which we have over there. For a student perspective, for an academic perspective, yes, you can work. Still the application remains same, still the hardware remains same. Implementation where you are going with the real time, yes, you can go with the real time there. Any biomedical departments you can easily use with this, or bioinstrumentations or medical electronics, easily you can use it for your different labs and you can do there. Still, it is not a clinical grade, but for a knowledge acquisition part, yes, you can use with these modules. So this one hardware for RF, whoever want to transmit your own broadcast to a different levels, yes, you can go with this kind of modules there. So these modules, different ranges and different parameters I have here. So I can use my own modulation schemes and algorithms. I can put it over to it, and I can work on any different applications, and I can take with it. And you can directly program this using a LabVIEW program. Again, your message signal will be your ECG signal, I'll do AM modulation, I'll send. I'll do FM modulation, I'll send. So I'll be doing a pure RF related applications and I'll be sending these data there. So these are the options what as of now we have there. So far, any queries you have? Probably I'll just stop for 5 minutes sharing. If you have any queries, I will just interact and we can continue with the others. Any EEG signal acquisition? Yes, we have EEG signal acquisition also. We have only thing what we need is we need to have a cap EEG acquisition and we need to acquire through the data acquisition models there. So hardware will be remain same, ma'am. One minute, give me a moment. I think for EEG, I have some modules also for here. Different sensors and options also we have. Uh, just take one case study for that. Excuse me. So if you see here, I have a case study. So where they use an NA DAC card. So they are acquiring and analyzing EEG signal with DAC and NA LabVIEW. So data acquisition card is same. The 6220 card will have a 16 analog input channels. So where you can connect different uh, electrodes to it, where you will be acquiring signals and you will be doing all your post processing with that. That will be the only difference. What you go with that. Apart from it, you may not do anything different. For me, acquiring data is the procedure. Then all my post processing, whatever I do, it is all up to my research activity. What I'm going to do. So data acquisition is common in all platforms. Whether I'll be working for ECG based or I'll work for a different options again. See, I didn't do anything beyond. I did something as a LabVIEW based. Over there. So I got these modules, these different caps I'll have over there. So there are very good NI videos also you have over there with that for EEG based options. And few what they'll give you is they'll give you something as a that will sense your brain signals and you can communicate with that and you can work. So many options are there. If you wanted to talk to someone, if somebody is paralyzed, if they want to make use of it, yes, still they'll be able to use with this kind of options they have. Please share link. Sure. Copy, paste. Done. So, excuse me. So we have multiple options there, and I just want to show you one particular video. So how exactly they are students are trying to use different projects with this particular operations there. So I'll just go for video solutions, studies, video, something else. Should be there's one voice control. Uh, I'll play through YouTube directly. Having yes. So this is a project which has done in 2012 for smart mobility for physically challenged. So for eye movement basis, they have done this. They'll try to identify uh, eyeball movements. They capture it. So based on the eyeball movements, they try to do the processing, and they'll try to transmit and receive it, and they'll be controlling it, the wheels using a motor driver. And they have a touch bridge motor driver for it, and they'll be using. And they have an obstacle sensors also they have kept with that. So if you see over there, there are different options. They are connected cameras. So they'll connect. So different eyeball movements position wise, it will be detecting which position is it. So they are creating a template for it, which is the eyeball. They are loading a template, and they'll try to identify where it is. Down, up, left, right. So they'll be moving out here. So this has been developed using LabVIEW there. So they have connected a camera, USB camera to their specs, and they are identifying it. So based on his eyeball movement, they are controlling a wheelchair there. So if you see in this, on the side they have a controlling unit, and laptop is always connected to this because the DAC card what they are using does not have a controller inbuilt in it. And something as a without computer it won't work. That's the reason they are keeping this with the computer always. So if they would have used this particular hardware, it has a computer in it, and it has a USB in it, and it has a encoder and PWM lines in it where they can control motor directly. they don't want to use. But this module has released in 2012, but this project competition started in 2011 itself. But they executed in 12. So students were not access for this. So they have different motors. Do you see over there? It is connected to motors are connected to this wheelchair. They have a different gear system which is controlling there in it. Excuse me. So this is the control board and relay boards what they have for it. And they have a motors and gearing units for it. A battery operated module. Battery for the DAC power card. If you see over there, there is no NI DAC system here. They are using one PIC microcontroller to do this work. This is what I was telling. It need not to be NI DACs. You can use any kind of DAC system. Any ADC or DAC, if you have microcontroller or microprocessor, still you will be able to write a program for them and make use for your applications. So yeah, that time they are connected to a Bluetooth and they use with it. Now we can connect with the IoT based something as a following, something as an object tracking, or you can use something as a communications, different modules you can use, or you can use an NFC technology also for your commuting within your house, and you can follow things and they can move over there with that. So this is one example where they are doing image processing over there. And they try to do something playful also. What they do it is they are controlling the system mouse with the help of their eyeball motion there. They try to play games with the help of their eyeball movement there. This is just simple options what they were trying to do with this. So this one literally 12, 15, 12, 13 years before what it is. This people have already done. So if we still wanted to do now also, yes, we will be able to do that. And simple one importance of 5G, if I want to tell you, for real time video or data transfer over there. There is a one very good Vodafone advertisement for 5G. So I'll just search for it. Vodafone 5G advertisement for remote operation theater from Japan. So remote surgery, there is one there. We will I'll just go for videos. So we'll get some YouTube videos there, nice YouTube videos. there is a different uh, options we have. I think I'm not getting that video. We get different options. So probably I can share you that video link. So there, how they will be doing it, they'll be treating for a person who is there in London. They'll be doing a surgery in London, but the doctor will be sitting in Japan. So they try to communicate and they try to feed informations through real time, and they have to get things done there. So for that, 5G is really important, because when you go for any IoT based devices, so what will happen here is it won't be a very easy option or a choice to connect to different hardwares over there in it, and every devices will occupy their own system there. So in a single room, what will be the bandwidth will go for it? If you are connected for 100 end user devices, think about around the globe. If you are going for a multiple billion mobile users or devices would be connected. Now when you get into an IoT, every device requires an internet to it. So how exactly we are going to serve that options there? For all those operations, we need a high speed, high bandwidth network over there for it. So that's the reason 5G will be one good option where you can use with this. Yes, 1 minute. I'll just stop sharing. Fine. So, any queries as of now? So, I'll just share the screen. So now, if you see for NI 5G, what are things that we need to have minimum if you want to work with it? Basically, we need a very good signal bandwidth. in order to act in order to achieve this particular signal bandwidth, we need to have a channel bandwidth. So what channel are we going to work? So who is going to be our infrastructure provider? There are in especially for your 5G networks, or whenever it comes over there, there are two people who are very much important in this. One is infrastructure provider, other one is end user node provider. Who are all infrastructure provider is obviously government. Second one is these carrier providers, Airtel, Geo, or BSNL, or Vodafone, AT&T, Orange, or different companies who is going to provide you this infrastructure to make use of the 5G networks. End user node providers are your mobile phone company manufacturers, your modem manufacturers. These are the people who are all end user node manufacturers, whether it can be a Broadcom, or it can be Ericsson, it can be Nokia, or it can be Huawei, or it can be your Alcatel, Realme, or Redmi, any Apple, any kind of people who are there in it. Unless until we don't have a system which runs on this particular network supported on the new radio 5G level, we may not be able to achieve that signal bandwidth over there in it. So obviously we need somebody to provide that infrastructure space. So who has to create the channels for us to access to use with it. So these two are the elements over there in it. So when we work on with 5G over there, this channel powers are really somewhere I can say it is important and more considerable part, or I can say it as nowadays it become as a worrying part, because earlier when we were using Nokia 1100 mobile phones, once if you charge the battery, what you are using in your Nokia 1100 were lasting for 3 days, but during that time you have only access to 2G. So you have only access to your somewhere as a 1 cross 1 inch of your system screen. Once the screen increases, once you started making use of the GPRS option over there, or edge options over there for internet, your battery started draining more. So they started trying to market with mobile phones which has a higher battery pack. So once you have a higher battery pack, so once you have your bigger screen size, your processor could not withstand for a high computational options over there. So the energy efficiency is a bigger portion over there. How exactly this energy efficiency part is gonna support over here? Because this particular data rate where you're gonna work, you need to have a higher energy, and you need to have a higher spectrum. These all mobile phone companies, I can say somewhere, they are trying to smartly uh, fool around us by mentioning or different advertisements over there. When they have released the 3G, they said that's the fastest, but 3G is not sufficient for us. So when they have released 4G in Airtel, still you can find an advertisement over there in YouTube. They used to tell your YouTube videos will not buffer. It won't rotate over there. It will be a seamless streaming. Be a girl who will be holding a Airtel mobile phone, which a 4G network over there. Behind her, there will be a giant wheel which will be rotating. They will say, this giant wheel may rotate, but your videos will not rotate. It won't buffer. That's what the advertisement says. Now, 4G also have gone. So now you got a 5G, which needs to be a high speed rate. But 5G is also not sufficient for us. All our videos started still buffering over there. And many places we don't have a 5G infrastructure. So where you will be switching between 4G and 5G over there, and your cell transition during your travel part. So many problems you have there in it. So those things will be addressed in your spectral efficiency, and you should not have any latencies over there in it, because whatever you're going to control over here on a 5G network, high speed network, a robot will be performing a surgery on behalf of you. So that will be really, really a critical one which we'll be working on it. So the importance of 5G is really, really matters. For now, 5G, what we will have it is our networks will not support 5G for a longer duration. Or I cannot say it cannot support for a larger distance as well. Because 5G uses a millimeter wave technology. These millimeter wave are high frequency technologies where you have a bigger bandwidth, but area of traveling will be less. So whatever millimeter frequencies you are going to work on it, which are very, very prone to, or which are very, very get more interferences with trees, buildings, and rains and clouds, different weather conditions also, you'll not able to get 5G networks properly. So what you have to do, you have to form a technique called as beam forming, different array of antennas you have to use for it in order to go with that, and you have to go for a variety of small cells where you need to deploy. We'll call it as a repeaters generally. So you need to have something. It won't be surprised when you are going to get a advanced version of 5G network, or you're going to get a advanced version of 6G network. You're going to get, probably you may need to install a mini cell phone tower in your home. Excuse me. Then only you will be able to get access for that particular networks over here. How exactly we used to get a separate dish antennas for our DTH, right? Similarly, we will be placing a small cells over there nearby places. Every houses will have one small cell which can cater at least the nearby people over there in it. So you have several parameters you need to have, which will be considered when you are working on a 5G data-based devices or 5G spectrum over there. Repeatedly, I was mentioning about that user devices, user equipments. So you need to have a high efficiency user device which can effectively communicate with the network. So you need to have a high computational device which should consume less battery so that it can last longer for it. And obviously, you'll have a path loss where you need to go for a different beamforming methods where you'll be using a different antennas for it. So these are all different parameters which you'll be working on your 5G applications there for it. So these are the different signal options and validation parameters as there with 5G part with respect to NI. NI is a very much pioneer in working on 5G and 6G relation activities. I'm just sharing you these things in chat, these links over there, so that any faculties, those who are working over there on RF, on a 5G, so you can easily reach to us so that we can have a detailed description chat. So how exactly we can use with it, what kind of hardwares we can discuss among them, and even for different products also, I'll just share you among them. So you can work on different options. I'm giving you a different variety of product pages. So it depends on your domain interest and research interest. I'm open to discuss. So it's hardly 8:45 now. We have another 10-15 minutes. I don't want to take much of your time because it will be 9. I'm sure everybody will be on transit or be there at home, or a few were there in colleges attending these sessions continuously. I have seen there was a earlier one more session also were there. So you would be attending this. So we don't want to take much of your time. So I'm open for your discussion. So whatever the queries you have over there, yes, we can take and we can discuss now. I'll just stop sharing it.
Dear participants, if there are any questions, unmute yourself, ask the resource person. Dear participants, if you have any questions, kindly unmute yourself, ask the resource person.
I'll even share my contact details. I think in the brochure you have, but still I'll put my contact details here. Yes, I just shared my details as well. So you're free to reach to me. We can have much detailed descriptions. If you want to have any detailed discussions, we can have.
Dear participants, if you have any questions, kindly unmute yourself, ask the resource person.
Hello? Has anybody worked on NI modules, LabVIEW, MyDAC, or something? Anybody have worked on it? Or is it something as a newly I introduced it to you?
Yeah, good evening, sir.
Yes, ma'am.
Uh, uh, First, we have to say thank you, sir. It's really the entire session was totally new to my yes. So it's thank you for your wonderful information, sir. I have learned
Thank you,
something
ma'am.
new from this session. Yeah, thank you so
Thank you.
much.
Thank you, ma'am. Thank you.
Yes, and these are the new devices for us. We have work on the IoT devices only.
Haha, haha. So, IoT devices are any devices which you have a capability of connecting to a network. Those things you can directly call it as an IoT. So, how
Yes,
exactly
sir.
I have shown a hardware called Myrio, right? I have a Wi-Fi. So, you can directly include that to your network and you can easily work.
Yes, sir. Yes, sir. We have used na a Raspberry Pi for that.
Correct, correct, correct.
Yes.
So, any Arduino or Raspberry Pis you can use with it. There will be only a small difference between that is the way you program the hardware will be different. And
Yes,
the
sir.
sensors how you are going to integrate would be if you are looking for some standard sensors, you can refer to these sensors what I have shared with you.
Yes, sir.
It will be close to a clinical level sensors what you can take.
Yeah,
Or else in
definitely. I
Amazon you
will
can find
order.
a normal sensors you can find. Some ECG
Yes, sir.
sensors or EEG sensors you can take. But the values what you may not rely on it. Because these companies, whatever I have shown you, they are all meant for academic lab packages they have. So they are into different academic operations they have there. If you see that they have a separate education level models also they have there in it. I'll just share the screen because these companies are there as standard companies which is there in US. You see over there the level of sensors what they have here. For elementary school levels, they have middle school, high school levels, college levels. They have different sensors they have. So these are all different packages what you get.
Yes, sir. I will try to buy this type of the kits and want to be set up this in our college.
Okay, so you're from which college? Your good name, sir?
Devbhumi University, Uttarakhand, Dehradun.
Okay, Devbhumi University, Uttarakhand. Okay, sure. You just try to reach me, sir, separately. I've shared my phone numbers and email ID there. Probably we can discuss much and we can configure setup.
Yes, sir. Sure.
Sure. Thank you, everyone.
Uh, Thank you very much, sir. I think there is no queries from participants for that. So
Sure, sir, sure.
shall we close the session, sir?
Yeah, sir. Yeah. Thank you
Okay.
for
Thank you very much.
your time and
Thank you
thank
very
you
much for
for
your informative session on lab view and 5G and some medical devices. Thank you very much, sir.
thank you, sir. Thanks.
Thank you, sir.
And I really appreciate your efforts as well as the participants over here because it's dinner time, but still they're not with their family, still supporting over here. So it's really a big kudos to all your faculties who are research scholars who are spending a time over here. And thanks for your time. Thank you,
Thank you,
sir.
sir.
Recording stopped.
Thank you, sir.
Shall I disconnect, sir?
Yes, sir. You can leave the.
Sure, sir. Sure.
Thank
Thank you, everyone. Good night to all.
Dear participants,
Thank you, sir.
feedback link is posted in the chat box. Kindly fill it. Tomorrow session will be started 6 p.m. Thank you very much.
ஆனா ஐயோ கட் பண்ண முடியல